Hey guys, this is Mr. Grice for Algebra Unit 10 Final Exam Review. Please ignore what it says at the top of mine where it says Algebra 1 or Algebra 2. It's not Algebra 2, it's Algebra 1. Alright, so, you guys ready? Number 1. Which correlation coefficient best represents the correlation graphed in the scatter plot below? So, what's the general trend of this graph? First off, is it positive or is it negative? Well, overall, it looks like it's going up. So right away, I can cancel out the negatives. Now, the only question is it 0.88 or 0.54? I don't know. Well, let's go back and look at our notes. So here I am at my favorite website. I'm going to Unit 10, and we talked about that stuff, linear correlation, on the very first day. So here are the notes. Let's take a look at what they say. Well, if it's between 0.8 and 0.1, it would be a strong positive correlation. And if it's 0.54, it looks like it would be weak. So would you describe that as weak or would you describe that as strong? Yeah, guys, that's strong. So that would be 0.88. All right. Number 2 says the scatter plot and table of values shows the relationship between the minutes a student studied for their math test and their grade in percent received on that test. Okay. So some of the things I noticed right away, that my time studying is the X value and the grade is the Y. Let's look at what the first one says. Calculate the equation of the line of best fit using the points 1568 and 4580. Well, let's see where those are at. 1568, let's see. This would be 10, so my next one would be 15. So we got that point right there. And then we have to do the same thing for 45. This is 50, so there's 45. So they're saying that that is the line of best fit. I like to see what the line looks like, so I'm actually going to draw it out. I don't know if the directions tell us to do that or not, but I think it's a good idea just so we can practice. So I'm using the straight edge. Hopefully you are too. And there we go. I think that's a pretty good line, don't you? Half of the points are below, half are above. All right, now let's see what it says. So calculate the line of best fit. How do I calculate the line of best fit? Okay, so to do that, the first thing we have to do is we have to find the slope. And we're going to do that by doing the y2 minus y1 over x2 minus x1. And then the second step is to plug into point slope, where we said y minus y1 equals the slope x minus x1. If you think you can do this, go ahead and pause the video and do it on your own. Otherwise, we're going to get started. Okay? So, y's are on the top. X is on the bottom. What's 80 minus 68? Okay, you should get 12, and 45 minus 15 is 30. We always want to reduce the fraction, and when we reduce it, we get 2/5. So when we come back over here, I'm going to plug in 2/5 for my slope, and now we just pick one of the points. I'm going to pick the one with the smaller numbers. So let's see, 68 was the y, and then 15 was the x. Okay, so go ahead and distribute. We get y minus 68 equals 2/5 x, and 2/5 times 15 is what? should have gotten -6. Okay, and then the last thing, to get the y all by itself, we have to add 68. And then our final equation is 2/5 x plus 62. All right, letter B. Using your equation, estimate the time a student spent studying for their math test if the student received a 65%. So, percent, was that the x or the y? Okay, that was the y value. So we're going to use that equation, but now we're going to plug in 65 for it. So, how do we solve? That's right, the first thing we have to do is subtract 62 to the other side. 65 minus 62 is what? Did you get 3? Good. All right, and to get the x by itself, we have to multiply by the reciprocal. So those cancel, and then we get x equals what? I got a decimal, so you should too. Yeah, 7.5. So if they got a 62% or 65% on the test, it means that they studied for 7.5 minutes. Hopefully you guys will study a lot more for your final. Okay. 3 says the table of values represents the data collected by ISAT on various students' IQ scores versus their creativity score. Sketch a scatter plot for the data and determine which type of regression would be necessary to find the function of best fit, if any. So, what you guys have to do is you have to, well, what do you gotta do? You gotta graph, okay? So, I want you to pause the video and try to graph these on your own, okay? So 140, 30, it says that your IQ scores are your X values, and the creativity score is your Y. So here's your Y, there's your X. I'll do the first point with you. So we would go to 140 and then go up to 130. That's our first point. And you guys do the rest. Pause the video, please. Okay, so that's the graph that I got. What do you think? Is this linear, quadratic, exponential, or none of the above? How do we have to calculate that? Yeah, it's not 100%, but it's pretty close to being a linear equation. Okay, so we would have to use the line reg if we actually had the graphing calculators and we were trying to figure it out. All right, the scatterplot and table of values shows the total pay and hours worked for several employees at Denny's. The equation of the line of best fit is y equals 10.92x plus 129.14. X represents the number of hours, and Y represents their total paycheck in dollars. How many hours did a person work if his paycheck was $578.86? So is that the X or is that the Y? Yeah, that's the Y, and they're telling us to find the X. So we have to be very careful where we plug this in. Okay, and now we're solving. We just did an example like this on the other side, so go ahead and pause the video, and I want you to do this on your own. Good luck. Okay, so the first thing that I did is I subtracted the 129.14 to both sides and got 447.72 equals 10.92x. Now, I had to divide 10.92 to both sides to get the x by itself, and we got 41. So our final answer was that that employee worked 41 hours. All right, number 5. A set of data is collected comparing the cooling temperatures of a freshly brewed cup of coffee after it is poured from the coffee cup into the mug. X represents the time in minutes, and Y represents the temperature in degrees of the coffee. The equation is Y equals 178.83.97 to the X power. What is the rate of decay? So that's what they're looking for, the rate of decay of the cup of coffee. So the two formulas that we talked about was the 1 minus b times 100 or b minus 1 times 100. One of those was growth and the other was decay. For decay, it's the first one. So this is the decay and here is the growth. So to find the rate of decay, 1 minus the b, which is 0.97, and we're going to times that by 100. Okay, if we're doing this step by step, 1 minus 0.97, if you have $1 and you take 97 cents away, you have 0.03 times 100, and 0.03 times 100 would be 3. And they're talking about 3% is the rate of decay. Okay. Mr. Ailes' physics class collected data on the height of a bouncy ball when it was thrown straight up from a student's hand. The equation of the function of best fit is that beautiful long thing right there. One of the things that I noticed is that's a quadratic. All right, so what will the height of the bouncy ball be after 2 seconds? And it says to round to the nearest hundredth. Okay, so the nearest hundredth means that we're rounding to the second decimal. So what do we do? I'm going to write a note real quick that that's the second decimal. So we have to take this beautiful long equation and we're going to plug in 2 for the x. Okay, so wherever there's an x, that's where we're going to put a 2. So go ahead and plug that into your calculators and tell me what you get. Oh, that's okay. I'm going to wait. Yeah, I'm waiting for you. You can do it. Now, the most common mistakes is that you're not going to put the correct numbers in, so be very careful. The calculator is only as smart as the person who's pushing the buttons. Okay, and you should get 1.749. Now, we need to round to the second decimal, so I look at the 9 because the 9 is going to tell me what to do with the 4, and it tells me that I need to round up. 5 or more, raise the score. So that means that the bouncy ball is going to be 1.75 feet. Okay, last one is calculating the residual of an actual data point. So this is our actual, and then this is the predicted. So when we're calculating the residual, we said that it was the actual minus, minus the predicted. Okay, and we're only care about the y values. Okay, so you would do 7.5 minus 4.2. Okay, and what do you get? Well, 7.5 minus 4.2 gives you 3.3. Okay, and that's it. Well, guys, if you have any questions on Unit 10 or any of the other units that we've gone over, please come see Ms. Carranza or myself. Other than that, that's pretty much the last lesson before your final. So we wish you the best of luck, and come find us if you need us. It's Mr. Grice signing off. Thanks for watching.